Hello everyone. Uh, in this video, we'll understand how do we solve an assignment problem, which is a balanced one and of a minimization type. So here, consider the following table of 4 children and 4 chores. Cell entries, the, uh, they are cost elements, means the cell entries, whatever is given inside the cells, 1, 4, 6, 3, 9, 7, 1, 10, 9, all these are cost entries. Means if second child is doing the third chore, it is going to cost 10. And similarly, if the fourth child is going to do second chore, it's going to cost 7. So this is the data available. From this data given above, we need to find out the optimal assignment schedule, means which child is to be given which chore, so that the overall total cost is minimized. That is what we have to find. So firstly, the very first step we need to check is that since the number of columns or number of rows is equal to number of columns, it is a balanced assignment problem. So that is the very first step to check whether the given problem is a balanced one or an unbalanced one. Here it is, number of rows is also 4, number of columns is also 4. So it is a balanced assignment problem. Further, the cell entries or cost elements, our objective is to minimize, the total cost. So, which means it is a minimization type problem. Minimization type problem. So first we have to reconfirm whether the given problem is a balanced assignment problem and also is it a minimization type of problem. Then only we will be able to use the algorithm which is called as Hungarian algorithm. So we will use this algorithm. Hungarian algorithm can be applied only for a balanced and a minimization type of problem. So now we are concluding that we will use Hungarian algorithm to solve this particular assignment problem. So the very first step in Hungarian algorithm is to do a row minima reduction. Row minima reduction. What is that? In each row, identify the least element, comma, subtract all the elements of that row with its least. So this particular step you will be doing it for all the rows. So we will create one table for this. Yes. Now let's see. In the first row, the least is 1. So I will be subtracting all the elements with 1. So 0, it will become 1 minus 1 is 0, 4 minus 1 is 3, 6 minus 1 is 5, 3 minus 2 is, 3 minus 1 is 2. That means 0, 3, 5, 2. 0, 3, 5. That will be our first row. 0, 3, 5, 2. Yeah. In the second row, the least is 7. Subtract all the elements with 7. So it will become 2, 0, 2, 0, 3, 2. 2032. 2032. Then third row, least is 4. Subtract everything with 4. So it becomes 0, 1, 7, 3. 0, 1, 7, 3. 0, 1, 7. Then in the fourth row, least is 5. Subtract everything with 5. 8 minus 5, it is 3. Then 7 minus 5 is 2. So 2, further it is 2, 3, 0. 2, 3, 0. So this is the reduced matrix after applying this row minima reduction, right? The next step is to go for column minima reduction. I will say this as our first step, checking for balanced or not. Second step is to check for whether it is minimization type or not. Third step is row minima reduction. Fourth step is column minima reduction. Column minima reduction. So it is very similar to row minima reduction. So in each column, identify the least element, subtract all the elements of that column with its least. So when we do this process, if a column has already got a 0 in it, you need not do this, because if I subtract it with 0, the elements will not change. So that means I need to focus on those columns where there is no 0. First column has already got a 0, second column has already got a 0, third do not have, last has a 0 in it. So only the third column I need to reduce it. Means let me create another table for this column minima reduction. The first column 0 to 0, 3, I will write it as it is. Second column 3, 0, 1, 2. Third column do not have a 0, so identify what is the least. 3 is the least. Subtract all the elements with 3. So 5 minus 3, it is 2. 3 minus 3, it is 0. 7 minus 3, it is 4. And the last one is 0. Then last column has got a 0, so 2, 2, 3, 0. 2, 2, 3, 0 will be the elements. So we had done this column minima reduction. Now the next step is review each row. Come on, look for presence of single 0 in it. So look for the presence of single 0 in it. If present, cover that with a box. That box we call it as assignment. So once an assignment is done in a row, any other zero present in the corresponding column needs to be crossed. Needs to be crossed. So in case if single zero is not present, single zero is not present, ignore that row for the time being. Ignore that row for the time being and move on to the next row. So based on this, let us do it. Review each row. Look for the presence of single zero in it. First row, does it have a single zero? Yes. So in that zero, cover that with a box. Once an assignment is done in a row, any other zero present in the corresponding column needs to be crossed. Is there any other zero in the corresponding column? Yes, here it is. Cross that. In case if single zero is not present, if you look into the second row, single zero is not there, more than one zero, time being ignore it. So ignore this row, go to the next row. We do not have any zero now, so you have to again ignore. Single zero not present, so you have to ignore it. Last row, again single zero not present, you have to ignore it. Same exercise needs to be done for columns also. Means first column, already assignment done, ignore it. Go to the next column. Is there a single zero present? Yes. Assign it. Once a column is assigned, any other zero present in the corresponding row, here there is one more zero, that needs to be crossed. Move to the next column. Is there a single zero present now? Yes. Assign it. Once I assign a column, any other zero present in the corresponding row needs to be crossed. So I need to cross this, right? Then this is what we could do here. We could do only 3 assignments against our desired 4 assignments. How I am saying 4 assignment? Because there are 4 rows, 4 by 4 matrix, we need 4 assignments. Desired 4 assignments. Okay, what is the next step? Next step, that is, I will say step 6. Tick all unassigned rows. Tick all unassigned rows. If a row is ticked, and if it has slash had, either it has or had a zero in it, then tick the corresponding column. Tick the corresponding column. Let us do this. Tick all unassigned rows. Only the third row is unassigned. Tick that row. Okay. Then it says if a row is ticked and if it has or had a zero in it, tick the corresponding column. This row is ticked. It had a zero in it here. Tick the corresponding column. Okay. Then next step. If a column is ticked, and if it has an assignment tick the corresponding row. Means this column is ticked and it has an assignment here, tick the corresponding. So I should do ticking here because this column is ticked. It has an assignment here, tick the corresponding. Repeat this. Repeat steps 6 and 7 until no more ticking is possible. Is possible. Okay, that means I should again check for the rows. This row is ticked. It has a 0. Tick the corresponding column. Already the column is ticked. No need to tick again. This row is ticked. It had a 0 in it. Tick the corresponding column. This column is ticked. It has an assignment here. Tick the corresponding. Means it is getting repeated again and again. So no more ticking is possible. Right. What is the next step? Step 8. Draw lines through unticked rows and ticked columns. Unticked rows and ticked columns. Okay, we'll go back here. Unticked rows. Unticked rows. Second row and third row are unticked. It says draw lines through it. Like this. These are the two unticked rows and then ticked columns. Only one column is ticked column. Draw lines through it. Right. Now, number of lines we could draw indicates number of assignments possible at that juncture, at that point or at that juncture. So here we could draw 3 lines, 1, 2, 3, and we had 3 assignments only, so it is matching. So it is just a check. In case if it is not matching, we will do some other step. Okay. Then what is the next step? Identify the least element. Identify the least element where no line is passing through, and call it as theta. Here, theta equal to what? Let us see that. Wherever line is not passing, that is this 3, 2, 2, 1, 4, 3. Among these numbers, which is the least? 1 is the least. So here theta is 1. Then what is the next step? Step 10. Subtract theta to those elements. Let me put it as 10a. Subtract theta to those elements where no line is passing through. No line is passing through. Okay. Then add theta to those elements where two lines are passing through. Two lines are passing through. Then retain the same elements. Retain the same elements where single line is passing through. Is passing through. So based on this ABC, we need to form a new matrix. Form a new matrix based on the above. Okay, let us do all this ABC on that matrix. Here, you may notice single line is passing through, so that means I should retain 0. Here, all these elements, no line is passing, so I should subtract theta, means it will become 0, 2, 1, 1. 0, 2, 1, 1. First row. 0, 2, 1. Because these three elements we subtracted theta. First element we retained as it is. Then come to the second row. Two lines are passing, so I should add theta. Means 2, I should add 1 because theta is 1. So 2 plus 1, 3. These things I should retain the same elements. So 3, 0, 0, 2. 3, 0, 0, 3, 0, 0, 2. Okay. Third row. Single line, so retain 0. These are all I should subtract. So 0, 0, 3, 2. 0, 0, 3, 2. 0, 0, 3, 2. Okay. Because first element has got single line, so I am retaining. These three I am subtracting. When I subtract 1, what happens? This becomes 0, this becomes 3, this becomes 3. That's why I said 0, 0, 3, 2. Okay. Here, two lines are crossing. So it will become 4. And here single line is there. That means I should retain. So what will happen? It will become 4, 2, 0, 0. 4, 2, 0, 0. Now what is the next step? Step 11. Repeat steps from what, wherever we had that step of assignment. Here, from step 5 onwards. 5 onwards. Again, anyway, I wrote repeat, right? So, first row, does it have a single 0? Yes, assign it. Since I assigned it, I need to cross this. Second row, no, it has got more than single 0. Time being, ignore it. Third row, does it have a single 0? Yes, assign it. Since I assigned this, here, any other 0 in the corresponding column needs to be crossed. So here, this has to be crossed. Fourth row, does it have a single 0? No. Time being, ignore it. Now do the column review. First column, already assignment done. Second column, already assignment done. Third column, it has got more than 2 zeros. So time being, ignore it. Last column, does it have a single 0? Yes. Here it is. Assigned it. Now, since I assigned this, I need to cross this because it is in the corresponding row. Done. Now again, once again, go back to row. First row already assigned. Second row, does it have a single 0? Yes. Assign it. Here, already assigned, already. We got now 4 assignment. So I should say we got 4 desired assignments. Hence, we reached optimality. because we got the desired number of assignments, right? So once we had reached optimality, I can write down the optimal solution. How do we present the solution? The first column, I will write assignment. These are all child actually. 1, 2, 3, 4. These are all chores. 2, 3, 4. Chores. So the assignment goes like this. First child is given the first chore because assignment is here 1, 1. Then second child will be given third chore. Then third child will be given second chore, and the fourth child will be given fourth chore, right? Now, let us see what is the cost given in the initial matrix for 1 to 1. 1 to 1 in the initial matrix, it is 1. I should write 1 there as a cost. Then 2 to 3 in the initial table, 2 to 3, what is the cost? 2 to 3, it is 10. So write down there 10. 3 to 2, go back to the original table. 3 to 2, it is 5. And 4 to 4 in the initial table, what is 4 to 4 cost? 4 to 4 cost is 5. So write down 5 over there. 3 to 2 is also 5. 3 to 2 is also 5. 4 to 4 is also 5. Right. So these are the costs. Now let us add up the total cost. This is 20 plus 1, 20. So 21 is our least cost. Least cost possible. So that is the optimal solution for this particular problem using Hungarian method or Hungarian algorithm. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.